Right, we're going to get going here again. If you're outside, like to come in, please come on in. If you're watching live, welcome back. Thanks for joining us. This session, we'd like to have everybody reimagine a little bit. Not just imagine, but reimagine. In about 30 seconds, we're going to welcome Hase with Big Switch Networks. And there it is. This is what he's going to talk about. It's not yesterday's networking. Reimagine networking as a cloud enabler. Alan, let's do it.
Thank you and good morning, everyone. Today I want to talk a little bit about reimagining a network using cloud-first principles in the data center. And fundamentally, I want to address a core question, which is why are data center networks always in our way? They're fixed, they're static, they're not agile, they don't enable a DevOps-like environment. So we're going to talk about this question, and then more importantly, we're going to talk about what do we do about it? Can we use cloud-inspired technologies to enable a data center network that is as agile and as DevOps-friendly as a public cloud? But before we explore this question, let's talk about what's going on in the market and why this is important. Why should we think about an on-premise data center network in the same construct as we do the public cloud? Well, the reality is there's been a race to move applications into the public cloud over the last several years. And before that, there was a race to build a number of data centers. So as you can see from a recent IDC study, over 80% of customers have one or more data centers, many of which have data centers both on-prem, multiple data centers on-prem, and many of which have multiple data centers in the public cloud, albeit Amazon, AWS, US East, US West, maybe places in Europe or Asia. They may have workloads in Microsoft Azure or Google. This is the reality that customers are dealing with. And unfortunately, as they make this move to public cloud and think about what applications make sense to be in the public cloud or on their on-prem data centers, they just don't have the tools to be able to navigate this world. Now, what is it that they're looking for? They're really looking for the same kind of thing on-prem in data centers as they are in the public cloud. They want speed and agility. They want a DevOps-friendly environment where the applications teams can define what applications they want to run, what tools they want to run them with, and how they want the network to enable their applications to interact with each other. They want to lower their capital expenses. They want to create vendor choice. Today, on-prem networks are fundamentally closed. We talk a lot about open innovation, but the reality is it's the same data center network that's been running with the same closed environment with fixed data center hardware and software converged together. There's fundamentally a better way for this. And fortunately, the ecosystem is really moving the ball forward in a very expeditious way here. There's a number of cloud-inspired technologies, open networking Linux, open networking hardware, which in the next 3 years is going to be nearly a quarter of all data center ports shipped. There's a number of other open technologies, such as free-range routing, that can be used to start to pull together an open networking environment that looks much more like the public cloud. So let's come back to the question that I posited at the beginning. Why are data center networks always in my way? Well, there's really several reasons. First is the network hasn't really evolved. We still largely operate a data center network in the same way we did 10 years ago. We use CLI, we have to type large number of commands. These commands are configured on a port-by-port basis, leading to very complex, very large configuration files, very difficult to innovate in top of that world. It's very difficult to create speed and agility when every box is running their own protocols, and not just one protocol, but everything from layer 2 protocols, VLANs and spanning tree, from running routing protocols and having to piece all of that together is extremely complex. It's also very difficult to use in terms of the number of boxes. There is no architecture. There's just a large number of boxes that have to be configured and orchestrated, each and every one of them manually. And last, it's all built on proprietary legacy, closed hardware, and closed operating systems. This really is not enabling the DevOps world that the public cloud has done. So, the way I see it, there's really two paths to sort of reach this hybrid cloud environment to give customers the tools that they desire to be able to run workloads both in on-premise data centers and in public cloud data centers. Now, a number of vendors have come out with sort of a vHardware-like approach. They've taken their legacy network operating systems and they've loaded it into the public cloud. They've built gateways and routing functions and things like this. But this is still the same virtual hardware capability that we've already had, that we've always had. It's the same port-by-port configuration. It's the same complex protocols. It's the same box-by-box configuration. There's really nothing different here. There's another way to think about this, which is really a cloud-first path. And the question is how can we take cloud principles and bring them into the on-prem data center to make it more agile and more DevOps friendly? This ultimately is what needs to be done in order to deliver a hybrid cloud environment for customers as they start to embrace multiple clouds and multiple clouds on-prem and in the public cloud. So let's talk about what this means to build a cloud-first data center on-premise. There's really three things to think about here, and we're going to explore each one of them. You really have to think differently. You have to think about bringing virtual private clouds on-prem. You can't take virtual hardware and bring it into the cloud. You have to take the fundamental building blocks that public clouds are built on and bring them on-premise. We have to think about monitoring and analytics consistently everywhere for security reasons, for monitoring reasons, compliance reasons. So it's really important to start to really see differently, to be able to see everything that's going on in all of my data centers on-premise and in the public cloud. And then we have to build seamlessly. We can't think about these data centers as on-premise data centers, US West, US East, and Amazon or Azure as independent, separate entities. They really have to be looked at as one contiguous data center that spans all of the environments that customers require. So let's talk about what it means to bring VPCs and think differently in the on-premise data centers. So first off, what is a VPC? It's a virtual private cloud. It is the fundamental building block in Amazon, Google, or Azure, which refers to these as virtual networks or VNets. But for the purpose of this discussion, I'll just use the term VPC. So VPCs are the logical building block. Instances, workloads run within a VPC. VPCs are configured in a public cloud to be able to set up routing policies and security groups to allow these applications to talk between virtual private clouds, virtual public clouds, as well as the internet. The one important factor here is that virtual private clouds have separated the logical networking aspect, what applications can talk to what other applications and how they do it, from the physical access of the network. Yes, there are still switches that run in all the public clouds, but that's really different. The user doesn't have to worry about these things. The application developer, the DevOps person, just worries about how to deploy their applications, how do they talk to each other, what security policies do they need in place to allow this type of access. That's really what they're focused on. They're not focused on the hardware port by port, command by command types of configuration. So they're also multi-tenant. You can have multiple individuals within an organization. You can have multiple customers all use these things. They have very delegated access principles as well. So why is this important? Well, the world has already voted. If you just look at Google search trends over the last several years, you can see that the search for VLANs is dramatically declining. Historically, VLANs have been the networking building block in the data center for many years. People are moving away from this. They care about how do I build virtual private clouds? And they want to do that both in the public data center as well as in their on-premise data center. So how should we think about this? Like I said, the one really important aspect of VPCs is that logical and physical networking is separated from each other. So in order to build a cloud-inspired, cloud-first on-premise data center, We need to think differently. We need to unbind the hardware from the software. We need to unbind the application access and the logical control of the network from the physical control of the network. In legacy networks, this is simply not possible. These things are tightly coupled together and are very difficult to abstract, unlike it is in the public cloud. So one way to think about this is to really think about how do we build a single data center network that looks like the cloud, that takes away all of the boxes and make it look like a single large virtual private cloud. That is really the question. So at Big Switch Networks, we've really built a fabric technology that addresses this very problem. We've taken cloud-inspired technologies from open networking hardware to open networking Linux, and we have built a networking fabric that makes the data center look like one big switch, not a series of independent switches that have to be managed box by box, not a series of individual ports that have to be managed port by port. And the reason for doing this is it brings that virtual private cloud technology on premise. It separates the physical aspect of the network, the ports, the physical hardware, from the logical access. Now, what this enables the DevOps person to do is to leverage their tools, whether it's Nutanix Prism or VMware's NSX or Kubernetes, to control the network in the way they want to control the network. They can deploy their applications, they can create VMs or containers, they can create the same types of security policies and routing policies on premise as they do in the cloud without ever having to ask the networking team to go box by box, port by port, and set up a network for them. The network is there to serve the application, not the other way around. It's a fundamentally different way in thinking about building a network, deploying a network, and leveraging a fabric technology in order to do so. Now, it also provides full automation and visibility, so you can see everything that's going on. So while the network operator doesn't have to worry about every single application that's deployed, how they speak together, they do get full visibility on what's going on in their data center. They understand all aspects of the fabric, but in the end, they worry about what they do best, which is the physical aspect of the network, and allow the application teams, the DevOps teams, to really take a CI/CD approach on premise as they do in the cloud. Now, there's another aspect of on-prem data centers that really have to change as well, and that is the way we build networks. Again, historically, you think about a data center network and you deploy a lot of top-of-rack switches that connect to a lot of servers. You may deploy end-of-row switches, core and aggregation switches, and you manage each and every one of these things individually. It's very tedious. But that's not how the cloud companies work. They don't build networks like this. They really think about a network as a core and pod-like design. They think about each of these sections to serve a specific need and to do a certain thing with a core set of routers that tie them together. So again, at Big Switch, we've thought very differently about this. We think about cores and pods in a data center much like a cloud-inspired company would. We think about how to tie legacy networks together, how to build brand new pods. You might think about a pod application as a brand new set of Kubernetes containers deployments. You might think about another pod application as a VMware installation, and yet another pod to be driven by Nutanix. You could also think about each one of these pods to serve all three of those needs with delegated administration such that a Nutanix Prism operator can deploy part of the pod and can control a certain set of applications and resources within that pod. You can also, in that same pod, enable a VMware NSX and or a Kubernetes deployment to happen within that pod, again with complete delegation and administration access. So you really have to start to think differently from box by box to really pod by pod kinds of deployments, and think about how we make it so that the DevOps teams can do what they need to do. So now, let's try and see differently. As we talked about, really there's a different way to build a data center network, but how would you see what's going on when you really want to have the data center on-prem and in the public cloud be thought of as one? So, the key challenge here, and this is an interesting quote from a CIO of a large government agency, they really look at their public cloud offer as a sprawling suburb. They started with a few applications in the cloud. They started with one region in Amazon, then moved to another region, and before you know it, they picked up other public cloud solutions and made other deployments, and they've lost complete control of what's going on in the public cloud. This is very typical in the industry. Often it's the applications teams that move first into the public cloud, and the networking teams are largely left out of the equation until something goes wrong. They either have a security concern that they need to address, or the virtual public cloud offers get very complex, and the routing gets very complex, and then the networking team is brought in afterwards. So the question is, how can networking teams engage in public clouds and on their own on-prem clouds to really see everything that's going on to deliver security, governance, compliance, visibility, to leverage the same sets of tools, whether it be offline firewalls or IDS, to really understand what's going on in all of their clouds? Well, the net is that on-prem data centers and public clouds use two different types of technologies today. If you think about an on-prem data center, historically, to get full visibility into what's going on in the network, you would deploy taps and a monitoring or a packet broker solution. Behind that packet broker solution, you would then put a lot of different tools together. You would start to think about different types of firewalls, application monitoring tools, networking monitoring tools, things like that, that you really start to build a visibility of what's going on. But that works very differently in the public cloud. In the public cloud, you have VPC flow logs that give you flow statistics of what's going on with all of the network traffic coming in and out of a virtual private cloud, going from one virtual private cloud to another within the same infrastructure, or within leaving the actual public cloud to the internet. Now, these things go into S3 buckets. They go into different capabilities like Elasticsearch engines, but it turns out that it's very difficult to actually pull all that together in a monitoring solution that works a lot like what customers are used to on-prem. This is a scenario where the on-prem solutions are actually far more mature than the public cloud data center solutions are. So let's talk a little bit about what Amazon is doing with VPC flow logs. Like I said, this is really an agentless approach. Amazon gives you access to everything that's going on within a VPC. You can look at it per subnet. You can look at it per VPC. You can look at CloudWatch logs, essentially a tool they've built to be able to look at what the packet flow looks like. And you get a lot of visibility into what's going on with all the security group rules, so you can see which rules are actually hitting and which ones the traffic's actually passing through. You get a lot of different analytics for it. So there's a whole workflow and a tenant-centric environment around that. So the question is, how do we bridge this on-premise mature market of packet brokers and visibility tools with the VPC flow log type concept in Amazon? Well, Big Switch has actually developed a set of capabilities. In fact, we just introduced a new product called Big Monitoring Fabric for the public cloud. We built Big Monitoring Fabric based on the need to be able to create a scalable monitoring and visibility and analytics tool for large enterprises. When you looked before Big Switch, the state of the art was really small deployments. You know, I want to tap a few racks. I want visibility into a couple of key flows. And I want to essentially broker packets from my data center network into a set of offline tools, typically firewalls and IDSs. But going forward, they really looked at this as, I want to see everything that's going on. Security vulnerabilities, east, west, north, south, can happen at all different aspects of the network, so I need to see everything. Well, as I go into the public cloud, I want to be able to use these same tools. In many cases, customers have built their own tools, their own monitoring solutions, or they've customized them, or they've used open source packages like Bro or Suricata for IDS, or they use other CloudWatch type tools to build into their data center. So what we've done is we've taken the same cloud fabric, the same monitoring fabric, and introduced it into the public cloud. We just recently introduced it into Amazon Web Services, and we did a demonstration for Microsoft Azure. What this gives network operators is the ability to monitor all of their traffic in the public cloud and on-premise, use the same kind of analytics capabilities, the same kind of monitoring tools, the same kind of offline tools that they might use for firewalls and IDSs, both on-premise and in the public cloud. This is a really important step because now it lets a network operator see everything that is going on in the infrastructure across their entire environment. They can now think about their data center not as a bunch of disparate independent data centers in US West, US East, on-prem data center 1, on-prem data center 2. They can think about them holistically across the entire environment. So now, let's talk about the third aspect. How do we see everything everywhere? Again, I think the goal of most hybrid cloud deployments is to really think about their data centers as one large data center. Really think about them as a cohesive set of offerings as opposed to independent deployments with different tools. So this is a typical situation that a customer might have. They might have a deployment in US East in Amazon. They might have another one in US West. They may have several more. And of course, they have their own on-prem data centers. They might have a brownfield data center where they've deployed existing applications and networking technologies. And they may be building a new greenfield data center as well. So Big Switch Networks has really taken this VPC everywhere concept and really driven it across the ecosystem. The goal is, if we think about all of these data centers as one entity that I can manage from a networking perspective, then I want to use virtual public clouds to be able to do that. I want to use VPCs in every single place. In my brownfield data center, I want to build different pods there. I want to build new pods in my greenfield data center, and I want to then leverage that same concept in Amazon and think about visibility everywhere. But then I want tools to give me full visibility. So we recently announced a new product called Multi-Cloud Director that gives full visibility to all virtual public clouds everywhere. You can have VPCs on-prem. You can have VPCs in the public cloud. You can have VPCs in different public clouds, and you have a single pane of glass with a world map view that shows you everywhere they are. You can then drill down into them. You can get inventory of the VPCs and where they're at. You can look at the types of switches and networking infrastructure that you have if it's an on-prem data center. You can then drill to the next step if you're having problems, you're seeing alarms and alerts, and really get this vast visibility into what is going on across the network. So the question is, which path do you want to take? There's clearly a legacy-first path, a vHardware path, one that preserves the status quo, that thinks about box-by-box configuration, that thinks about sampled analytics and disparate tools between on-prem and in the cloud. There's one that thinks about trouble tickets and maintenance windows. Every time an application team wants to deploy a new application, more trouble tickets, more maintenance windows. There's one that wants to keep the network as independent silos or a legacy TCO. Or there's a cloud-first path of tomorrow, one that starts to think about VPCs everywhere. One that starts to think about the hybrid cloud as one cohesive asset with complete visibility and flow analytics in the public cloud as well as on-prem. And one that thinks about VPCs as a service culture, one where the application teams can really be DevOps teams on-prem and in the cloud, moving the network from a fixed silo to a fully managed DevOps environment. One that thinks about cross-infrastructure collaboration, where the networking teams and the operations teams and the application teams are also working together. And one that has a cloud TCO that's completely transformative in how we operate the network, both from a CapEx and an OpEx perspective. So with that, I thank you for your time. You can visit us at the Big Switch Networks booth just outside. Thank you.